So hi, welcome to the lecture 5. So today let's see theorem 3.3. Theorem 3.3 says that a by p equals to minus 1 whole power t, where t is a sigma j equals to 1 into p minus 1 by 2 into ja. So we need theorem 3.2, that lemma of Gauss. We will use that lemma of Gauss in this theorem. Okay, if you don't see theorem 3.2, go and watch that monster video 15 minutes video. No need to watch this video. Okay, just go through notes. Okay, sir notes, that's enough. Okay, fine. That is very bad. I made it a very so much big, so I want to cover as minimal means. In this video we will wind up very fast. Okay, so consider GCD a comma 2p equals to 1. So GCD is a comma 2p equals to 1. So observe that. See, what do you mean by GCD? GCD means just greatest common divisor, means common factors. Divisor is also known as factor. Okay, the word name divisor is also known as factor. Okay, happy. So consider a, what will having a like this, it is having the factors. These are called factors. Okay, what does 2p has factors? 2p and 2p. Okay, now we are saying that both having GCD equals to 1. That means that all these values are there now. So 2 doesn't divides all these values, means x means it is the factors which is all the factors. Okay, all the factors of these things including a. Okay, this let's say this has a set x, so 2 doesn't divide this set xi, and p doesn't divide this set xi, and 2p doesn't also divide xi. Okay, these things we can derive from this given information. Okay, this is the main thing, you have to observe this. So from this what we can conclude? So basically on the whole summary, like this means that we can say 2 doesn't divide a na? Xi means what? Xi is all the factors except 1. Let's say suppose take a as a 15, then what will be the factors of a? 1, 3, 5, 15. So I'm saying except 1, these all things as a x. Okay, so 2 doesn't divide ca. 2 doesn't divide ca means we can say that a is a odd number. Okay, this is the main first conclusion. And next one is that p doesn't divide ca. P doesn't divide ca. That means a is not a multiple of prime number p. Okay, this is the things we can derive it. Since a is a odd number, can I write a percent 2 as 1? Yes or no? Yes, right. Percent means what? Modulus. Okay, mod, I mean think like a mod 2 equals to 1, because for every positive odd numbers, when we mod with 2, it will always gives 1. This is the main thing you have to know, keep in your mind. So this is what you can derive it. Now just this is Euclidean division algorithm, I think. What is a equals to bq plus r, where q belongs to z and r is less than b, r equals to 0 less than r equals to r less than b. So I can write like this. Okay, a equals to b into q can be written as box of a by b. So this is called as GIF. GIF means greatest integer function, means floor function, means like 3.5 how much? 3 minus 4.5 how much? Minus 5. These things I have discussed in the L1 lecture, you can see about it, no need. And plus r means what? R can be written as remainder. Remainder is nothing but we can write like this, no? Okay, this is basic funda. Okay, now I will use this result only. Okay, so again let's recall theorem 3.2. so what we have taken means, initially we have s mod p set, means let's say let's start very newly, okay, freshly. Let's see S be a set which is having these values a comma p, b comma p, to a percent p, and so on, p minus 1 by 2 percent p. Okay, did you observe one good thing, that p doesn't divide ca and p is a prime number? So can we conclude from these two that GCD of a comma p equals to 1? Yes, it is true. Okay, GCD of a comma p equals to 1. So if I know GCD of a comma p equals to 1, what is the meaning of that? So we can apply theorem 3.2 here. Yes, of course. What is the main basic criteria for 3.2? is that p is a prime number and a is a some number such that a comma p equals to 1. So I can apply here directly. So for this given information, from this I have concluded that what I have concluded, main big results, important one, that a is a odd number, and the second one is a comma p GCD is 1. Okay, so from this I can directly write that using this 3.2, what can I write? A by p is equals to directly minus 1 whole power n. Samjha? Happy? Okay, nice. Where n is that in this set how many numbers exceed the p by 2, that is the value of n. Okay, so now our main aim is that we have to prove that instead of a by p equals to minus 1 whole power n, instead of n we have to write this one. We have to make this good looking this thing. Okay, how to make this? This is all about this is we will see in the proof. Okay, instead of n we can write n, that is equals to what they are saying means minus 1 whole power this value. Let's name it as a t. Okay, now we have to show that n and t are in a way are same equal. Okay, that is our thinking process. So in that direction we have to move out. So again we will use this basically funda, means theorem 3.2. so let S be the set of like something blah blah blah, and I told no, let's set b1 and let's set b1. okay, b1 b2. okay, b1 b2 li, and b2 how much? b2 equals to ri, where I equals to such that where ri is greater than p by 2. What is ri? Ri is nothing but a into j mod p. Percent means mod p. Okay, so aj mod p. This is the thing where here li less than p by 2, where li equals to aj mod p. So we are having like this. So if you go and watch this lecture L4, we have seen that we have considered a set S dash such that we are having p minus ri and li, let's say lj, for I equals to 1 to n. So this set is having 1 to n, and this set is having 1 to some how many elements, p minus 1 by 2 minus n. Okay, this everything, this details we have discussed in the L4. You go and watch it. So okay, this is this thing. So I have proved that all elements in S dash are distinct. Okay, all the elements in S dash are distinct. Okay, all elements are distinct, and basically S dash is nothing but like this, exactly equal. Okay, exactly equal. Happy? Okay, happy. So that's it. So after that what we have to do means so can I write like this, sigma j equals to 1 to p minus 1 by 2. Okay, basically sum of these elements is nothing but these elements, sigma p minus ri, where ri 1 equals to 2, plus sigma j equals to 1 to here j equals to 1 to j equals to p minus 1 by 2 minus n, p minus 1 by 2 minus n. So what can I write? Pn minus sigma ri plus sigma lj. Okay, this is sigma j. Okay, now consider this set. Consider this set. So in this set, according to this set, do this, no, not this set, consider this equation. Okay, what is it saying? That this is the equation 1, make it. So from this what I can write means, let take a be some, I want in this format. Okay, sigma aj, sigma aj, and b equals to, means I mean this a equals to sigma into aj. What is a here means according to ours a, this a I am saying. Okay, wait, consider b as a p. So what will happen? Tell me. Sigma aj, where j is running to 1 to p minus 1 by 2 equals to p into that what that, array man, I'm saying that aj equals to p into aj by p plus aj mod p. Happy? After that what I am saying means, apply sigma on both sides. Sigma on both sides. What will happen? Sigma aj, sigma p into aj by p, sigma aj mod p, where j running to 1 to p minus 1 by 2, j 1 to p minus 1 by 2, 1 to p minus 1 by 2. So what will happen? A into sigma j, j equals to 1 to p minus 1. We know that 1 plus 2 plus 3 and so on n. What is the value? N into n plus 1 by 2. So similarly here n is the p minus 1 by 2. So what will happen? Tell me, what is this value? P minus 1 by 2, p minus 1 by 2 plus 1 by 2. How much? Total p square by 8. So okay, p square by 8. So this value whole is nothing but p square minus 1 by 8, that is equals to sigma p into aj into p. P can be pulled out. Sigma j equals to 1 minus p minus 1 by 2 plus. So here what is aj mod p? Okay, aj mod p, sigma j equals to 1 minus p minus 1 by 2. Here remember one thing. Okay, remember one thing. Can I write, we know that, see, b1 union b2 is what? Yes. So basically li comma ri, this set is nothing but aj mod p, na? Am I right or not? Array man, see carefully, I am saying this. This is nothing but, see, first of all, what does this term mean? Summation of all the, this is a sigma aj mod p. So that means summation of all elements in the set S. So we know that set S is equals to b1 union b2. So summation of all elements in S is nothing but summation of elements in b1 plus summation of elements in b2. So can I write this as like this? Sigma ri plus sigma bj. Okay, happy? I mean bj, sorry, not bj, it's a lj. Okay, happy? So after that what will you take? A into p square minus 1 by 8 into p into sigma j equals to p minus 1 by 2 ajp plus sigma ri sigma lj. I am not writing here, like again you, this is like you understand little bit. Okay, no need to write deeply. Okay, this is the equation 2. I am saying that do equation 2 minus 1. So this is 1. So what will happen means, basically by doing 2 minus 1 I will eliminate the lj. Okay, so what will happen, tell me? A minus 1 p square minus 1 by 8. Why p square minus a minus 1? Because here sigma j is nothing but again a into p square minus 1 by 8. Okay, I mean sorry, only 1 into p square minus 8, right? A minus 1. Okay, that is equals to p into sigma j equals to 1 p minus 1 by 2 aj by p plus 2 into sigma ri. Okay, now applying mod 2 on both sides. So what will happen, tell me? So a minus 1 p square minus 1 by 8 mod 2, okay, into p sigma into aj by pj mod 2 plus 2 into sigma ri mod 2. So I'm saying let's take as a sum k. So 2k percentage 2 equals to 2% 2 into k percent 2 whole power 2. So this value is 0. 0 into anything is 0. 0% to 0. Happy? So this whole term, chalo, bye bye, ticket. Okay, it becomes 0. So next what to do? Wait again. Array man, we missed this term, you didn't tell me. I forgot to write, sorry, my mistake. So what will happen? Minus np. So minus np percent 2. Okay, whole percent 2. Okay, you got my point? See, this is looking like a sum x equals to x1 plus x2 plus x3. So now what I did means x percent 2 equals to x1 plus x2 plus x3 percent 2. So what will I have written separately? x2 percent 2, x3 percent 2, whole again percent 2. This is the property. I have discussed so much detail in the previous classes. Now I want to end it in very fast again, but still it's taking so much time. Okay, percentage 2. Okay, and after that what is happening? That's what I have written like this. So this becomes like 0 here, and this is as it is, let it be. And what will this value will become, tell me? np percent 2. So np percent 2 is equals to n percent 2 into p percent 2 whole percent 2. Okay, what is p percent 2? P is a prime number. So p percent 2 is how much? 1, right? So n percent 2 percent 2. What is again? This is looking like a n percent 2. Happy? Okay. Okay, so next what to do means, so write this here, a minus 1 p square minus 8 percentage 2 becomes p into sigma aj by p whole mod 2 plus n mod 2 percentage mod 2. So this can be written as aj by p, sorry, minus is there, so this is minus. Okay, samjha, n whole percent 2. So a minus 1 p square minus 1 by 8 percentage 2. So now see here, if you believe me or not, okay, if you believe me or not, what is a is a odd number. Okay, so then it will be of the form something 2k plus 1 where k belongs to z. It is of this form. Okay, and p is a prime number. Prime number means odd. So let's say 2k plus 1 something 2k to another variable k2 belongs to. So evaluate this value. Okay, first. So what will be the value will become, tell me? 2k2 plus k2 by 8. So k1 k2 into k2 plus 1. So now observe that a minus 1 p square minus 1 by 8 whole percent 2 equals to k1 k2 k2 plus 1 whole percent 2. So this can be written as, take this as a 1 and this as another one. So k1 percentage 2 percent, I mean modulus 2, k2 into k2 plus 1 percentage 2 whole percent 2. Now if you observe that we know that multiplication of two consecutive numbers is always divisible by 2. Why so? Because in the term, in these two numbers, one must be even, another is odd. Samjha? If you don't feel, then again you can prove this thing. Like you can keep like k is like you consider two cases, like k can be of the form 2k3, or k is of the form it is even case and it is an odd case 2k3 plus 1. So you substitute here like 2. In this even case, what will happen? 2k3 into 2k3 plus 1. So here since 2 is there, it becomes 0. So if I keep here 2k3 plus 1 into substitute 1 plus 1, how much? 2k3 plus 2. So 2 common means okay, again 2 is there, 0. So basically all I wanted to say is this whole value will become 0. So 0 into anything is 0. So basically this whole value is become 0. So LHS, if you go here, LHS become what? 0. So now I can conclude that what I can conclude. So this can be written as how, like how means like 0 is congruent to p sigma aj by p minus n whole okay. You got my point. Not like this. So 0, so 0 equals to some x percent 2. So from this what can you conclude? Tell me. X can be written as 2 into some q, where q belongs to z, plus remainder how much? 0. So x equals to 2q. okay, x equals to 2q means like that. So what will happen? This value will become p into sigma aj by p minus n equals to something 2q. Samjha? So p into aj by p minus 2q equals to n. So since we know that a by p equals to minus 1, to tell like this, what is the minimum condition is that p is a prime number and a comma p GCD 1. If it is happens, so we can tell like this. So we have seen that a comma p equals to 1 GCD. Why so? Because we have tell clearly, neatly that from this point I can arrive to these two. So after that what will happen? This is by theorem 3.2. So I can write in place of n, what can I write? Exactly this value. So p into sigma aj box minus 2q. So this can be written as p into sigma. So they are saying that take this value as a t. Okay, okay. See, again I have done small mistake, so sorry. I have become overlooked. So again we can simplify this this thing. How means I will tell. So it is percentage 2. When it again, see, it should be here whenever p into sigma aj by percentage 2, I can write this similarly. This concept according to the same steps I can write like this. I can leave p as a 1. okay, because p percent 2 how much? 1. So this is how. So finally leave about p here p ledu. Okay, okay, and aj by p into minus 1 whole power minus 2. So this means that 1 by minus 1 whole power 2 square. So minus 1 whole square whole power q how much? 1 power q into 1. So overall 1 by a. So a by p equals to minus 1 equals to t. Okay, happy? This is small proof. Okay, tata, bye bye. Now wait. Proof is done. Like I have done some in previous videos, I have done some mistakes. What mistakes means I have become overlooked. So see, whenever I am having x congruent to y mod p, if it's I am having, then I can conclude that ax equals to a mod p, where a belongs to real numbers. Okay, it's completely real number. It can be anything, no problem. It's anything, no problem. This I can conclude. If I am having like this, then can I directly cancel like this, like normal bacha? Answer is no. Can I, my question is that if I like this, then can I write like this, x congruent to mod p? Answer is no. I can write like this only when some other condition is there. So I will write like this, a is congruent to ay mod p, and a comma p. See here, let's say take m can be anything, need not be a prime number, m can be anything. Okay, this is true for anything. So then, and a comma m equals to 1, then I can write successfully x congruent to y mod m. Okay, happy? So if you observe in yesterday proof, in yesterday L4 class, so I have told that like something, I have told that p minus 1 by 2 is congruent to minus 1 whole power n a power p minus 1 by 2, p minus 1 by 2 congruent mod p. So now yesterday in the video I directly cancelled, but why I have cancelled? Why means the reason is that now observe GCD of p comma p minus 1 by 2 factorial, how much? If it is 1, then I can cancel successfully. Okay, I can cancel successfully. Why so means because of this theorem. But I don't know what is this value of this. So in SNS we have one theorem. Okay, this normal number system theorem is, what is that number system theorem is that if a comma n equals to 1 and b comma m equals to 1, then I can write a b comma m equals to 1. I can multiply and I can write like this. Okay, happy? So now consider these values. P comma 1, how much? 1. P comma 2, how much? 1. P comma 3, see, p is a odd prime. Okay, so don't worry here. P comma 3, 1, and so on. P comma p minus 1 by 2, how much? 1. So according to this extension of this one, what can I write? GCD of p comma p minus 1 by 2 and so on 1. So this whole thing will become p minus 1 by 2 whole factorial, that is equals to 1. So since this is equals to 1, I can successfully able to cancel it. Now after I cancel it, now I have written like minus 1 whole power is congruent to a minus 1 by 2 mod p, and then we know that previously, it is nothing but we know a by p is congruent to a minus p minus 1 by 2 mod p. So from these two equivalence relation, I can write minus 1 equals to a by p mod p. So from this one, minus 1 mod p equals to a by p mod p, and since this value always will become just 3 values, minus 1 1 0, I can write directly a by p, and this is minus similar. So like this how it works. Okay, happy? You understand my point? Okay, fine. Thank you then. Bye bye. We'll see you in next video.